We are on day 2 of limits, and we're going to focus on looking at limits algebraically, mostly today. Yesterday we did a little bit with that where you could just plug the number in and it worked great. Here's when that's going to work great. If it's a polynomial function. Because they're continuous, they don't have those gaps or asymptotes or anything whole in the graph, nothing. Because they're polynomial functions, they're easy to find the limit. You're just going to do the direct substitution. So that is always a go-to if we've got a polynomial function. Today we're going to look at, yeah, but what if it's not? Like, for instance, a rational function. They're not continuous. You may have to try some other strategies. So our first step is substitution, because maybe, just maybe, even if it was rational, maybe the c isn't really approaching where the asymptote is. If it's approaching some other spot on the graph, that's fine. I don't care. I'll just go see what it's approaching. That asymptote doesn't ruin it for me unless that's what my c is approaching. If it is approaching the asymptote, we've got some other things we're going to try today instead of just bailing and going. I mean, you can still always do the table. You can do the graph. You could still have that option. It may be a no limit exists. It may be fancier than that. Who knows? Let's try some. Now, here's some examples of what I'm talking about. Here's a polynomial function. See how this is a beautiful little quadratic? That's a continuous function. Let's plug -1 in and do direct substitution. If you put in -1 and square it, you get 1. Put in -1, I'd have a -1, and then a -6. That's going to end up equaling -6. Quick and easy. It might be rational. But let's look at what x is approaching. Do you see how it's approaching -1? And that is not where my asymptote's going to be. I'm just going to plug in -1 and I'm going to be fine. In my numerator, if you'll notice, I picked the same function that I had right here. So I know when I plug in -1, that's going to equal -6. The numerator is -6. The denominator when I plug in -1 is 2. So that's going to divide out. The limit's going to equal -3. I could look at those with a table. I could look at those with a graph if I needed to. What if you can't substitute? Looking at this example here, this is irrational, or not irrational. It is a rational function because it looks like a fraction. Notice that what I'm substituting is the exact same that's going to create a problem in my graph. But here's the deal. That isn't necessarily an asymptote. Which if it was an asymptote, I'd have to say no limit exists. But let's look at what would happen here if I went ahead and factored, because that's what I'm going to try to do here. I'm going to factor, and I'm going to hope something will cancel. If you factor that numerator, it's going to be factors 2 and 3. I'm going to have a +3 and a -2. And if you look at your denominator, you already have an x plus 3. Those two guys can cancel out. This whole rational function actually reduces to just an x minus 2 function. And an x minus 2 function is really linear. If I were to look at a graph on this, it's a linear function. It has a y-intercept of -2. It has a slope of 1, and it would look like this. The only problem is because of the way it was originally written, there's something going on right here at -3. And what it is, when x is -3, somewhere down here, there's a hole in that line. And you won't notice it on your graph, on your calculator. It doesn't show the hole. But if you were to try to evaluate that limit and try to do direct substitution or do anything at -3, you're not going to be able to find what that y value is. Now, that doesn't mean the limit doesn't exist. Remember, a hole we can work with. With a hole, you can say, well, as my x gets closer towards that hole from both directions, what's the y value getting closer to? Well, I can find that now with my direct substitution. This line is really just an x minus 2. I can now take the -3 and plug it in right here. And if I do the direct substitution, I get a -5. So this spot right here, the y value would be approaching -5. Let's take a look at a function that has a radical in it. We are used to seeing functions with radicals, and typically what we like to do is rationalize the denominator when we have those. We're going to try rationalizing the numerator. When you rationalize the denominator or the numerator, it doesn't change the value of the problem. All it does is kind of rearrange it so that it looks different. Right now, I can't do direct substitution, but maybe if I rearranged it, something would simplify to where I could do direct substitution. I'm going to give it a shot. Typically what I would do when I see this square root in the denominator, I'd have to multiply by the conjugate. That's what I'm going to do. I'm going to multiply by the square root of x plus 1 plus 1. I'm going to do it on the bottom also. Now in the denominator it's going to work much nicer. Don't try to get a lot done by like trying to distribute the x. I'm just going to leave it out there for right now. Let's look and see what's going to happen in that numerator when I rationalize it. Just keep the denominator the same. In the numerator I'm going to end up doing FOIL on this. Look at what happens when you multiply the first. They're identical. They both have a square root. So those square roots are going to end up going away, and I just have an x plus 1. Recall that the reason we choose to multiply by the conjugate is because anytime you do the outer, square root of x plus 1, times and the inner, which is a negative square root of x plus 1, they always cancel. That's why we picked the conjugate. So my outer and inner are gone, and my last is negative 1. And that works beautifully because a positive 1 and a negative 1 will cancel. And this x that I have left is going to reduce with this x, and I'm left with just this conjugate function that I have in the denominator. After I've rationalized, I end up with a 1 over the square root of x plus 1 plus 1. Let's see if that helped us so that we could try some direct substitution. If you plug 0 in for x, you'd end up with the square root of 1, that's 1, plus 1, that's 2. I think this is going to work beautifully. I'm going to end up with a 2 in my denominator, so the limit is going to equal 1/2. Anytime we see those radicals, that's going to be our method, is to try to rationalize the numerator. I have one more that we're going to try. I don't want you to forget that substitution, or that algebraic way of that direct substitution, is not your only option today. We still have the table, we still have the graph. So if you struggle with a problem on your homework because you can't figure out how to do it algebraically, then I would expect that you're going to create a table for it, or you're going to graph it and look at what happens. So here's one that I look at like, I'm not sure what's going to happen with this thing. I can't tell. Algebraically, I don't know what to do. I can't cross x's out. That's not going to work with a sine function. I don't know what to do. I'm going to go to my calculator. I'm going to go into, especially with trig ones, I really don't know a lot of times what I'm doing with that algebraically. So I'm just going to go sine x, close your parenthesis, divided by x. And let's see what that's going to do for us. Now, I can't see very much. It looks like a little hump in the graph there of some sort, but it still goes below the axis. I'm going to zoom in once and see what happens. You should be doing this on your calculator. Okay. So this is what I see on this graph. Now, I zoomed in and I lost the edges of this, so I'm not real sure then what's going on outside of that. So let me fix my window real quick and make my x go to -5 and +5 so I can see a little bit better. Yep, it's underneath the axis there. I don't know. I'm just going to sketch it in here. It does something like this. Oh, that's bad. I'm going to try again. Because it's all very symmetrical looking. That's what I see on the particular window I have. I'm not too worried about the edges because remember, I'm looking at what's happening when x approaches 0. So I'm looking at what's my y value getting closer and closer to, What's my y value getting closer and closer to? Now, if I were to look at my graph, it looks like it's crossing at 1, but I can't do direct substitution to find that. So I'm going to go, since I have it in my y equals, I'm going to go to my second trace button, and I'm going to hit value, and I'm going to type in 0. I'm going to try it, direct substitution. I got a blank back on the y equals. I think what that means is there's probably a hole right here that I can't see on my graph. Don't care. Remember, looking at what it approaches. What's it look like from your graph that it's approaching? It should be 1. And you can do a table to check that. The limit is equal to 1. All right, so lots of algebra stuff today. Go have fun doing math. Go have fun doing math. See ya.